Well, hello. I'm very delighted that you have joined us again for yet another episode for your CXC chemistry. Today, we want to look at yet another topic. I encourage you to get your pens, paper ready for writing and taking the notes that are appropriate. I wish you the best in your pursuit. Remember, you can do it if you commit yourself a little a day reviewing the work that you would have covered in school, going over revision guides and answering the necessary questions in preparation for your exam. So I wish you the best in this pursuit for your success. Today we want to look at the topic mixtures and separations. I want to get some definitions out of the way and to remind you that definitions are to be learnt because they will be recalled at the examination. And so here we go. Definitions. Elements. Elements are substances that are made up of one type of atom. An element cannot be broken down into any other substance. How about a compound? Compounds are substances made up from atoms of different elements joined by chemical bonds. They can only be separated by chemical means. A molecule. A molecule is a group of atoms that are joined together chemically. Now, we need to also look at what is referred to as pure substances. Pure substances. A pure substance is a homogeneous substance. It contains only one type of atoms or molecules. Pure substances mainly have a constant or uniform composition throughout. Pure substances have fixed boiling points. They have fixed melting points. A pure substance would participate in a chemical reaction to form a new product. How about mixtures? Mixtures are made up of two or more substances that are not chemically combined together. I repeat, that are not chemically combined together. The parts of a mixture each keep their original properties. The parts of a mixture can be separated easily. The proportion of the parts of a mixture is variable. The boiling and melting point of the mixture depends on the characteristics of the components in which it is made of. During the formation of a mixture, there is no energy change because it is a physical process. Types of mixtures. Generally, there are two types of mixtures. There is what we call a homogeneous mixture and two, a heterogeneous mixture. Now, what is a heterogeneous mixture? A heterogeneous mixture possesses different properties and compositions in various parts. The properties are not uniform throughout the mixture. And how about a homogeneous mixture? A homogeneous mixture is defined as the mixture that possesses the same properties and combination throughout the entire mass. We turn our attention now to a suspension. A suspension is defined as a heterogeneous mixture in which the solid particles are spread throughout the liquid without dissolving in it. The solid particles are large enough and will settle on standing. The particles of a suspension can be seen easily. The particles of a suspension will not pass through filter paper, and therefore a suspension can be separated by filtration. A suspension would scatter a beam of light that passes through it because of the large particle size. Common examples of suspensions will include muddy water, milk of magnesia, and sand particles suspended in water. A colloid. What is a colloid? A colloid is an intermediate between a solution and a suspension. A colloid is easily observed and visible to the naked eye. What is a solution? A solution is a homogeneous mixture of substances. For example, when salt is dissolved in water, a homogeneous mixture or solution is formed. The component of a mixture that is present in the greatest quantity or that determines the state of matter of the solution is called the solute, and the other part is called the solvent. In solid solutions, both the solute and solvent are in the solid state. For example, polymers. In liquid solutions, solid, gas, or liquid is mixed in a liquid. And in a gaseous solution, the homogeneous mixture is really comprised of gases. For example, air is a mixture of gases. There are different types of solutions. Depending upon the amount of solute in the solvent, solutions can be classified as being supersaturated, unsaturated, and saturated. A supersaturated solution comprises a large amount of solute at a temperature when it will be reduced. As a result, the extra solute will crystallize quickly. An unsaturated solution is a solution in which the solvent is capable of dissolving more solute at a given temperature. A saturated solution is defined as a solution in which a solvent is not capable of dissolving any more solute at a given temperature. We also would hear of an aqueous solution. An aqueous solution is when a solute is dissolved in water. An aqueous solution is when the solute is dissolved in water. The resulting solution is called an aqueous solution. Then there is the non-aqueous solution. This is when a solute is dissolved in a solvent other than water. The result is a non-aqueous solution. A dilute solution contains a small amount of solute in a large amount of solvent. A concentrated solution contains a large amount of solute dissolved in a small amount of solvent. When two fluids are combined to form a solution, they are considered miscible. When two fluids are combined to form a solution that cannot be mixed, they are said to be immiscible. Alcohol and water will form a miscible mixture, while oil and water are immiscible. They will not mix. Solubility. Solubility often depends on temperature. The solubility of a substance generally will increase with increasing temperature. You see, as temperature increases, the kinetic energy increases, and it allows the solvent particles, the solvent molecules, to move quickly, breaking apart the solute molecules that are held together by intermolecular forces. So we say that solubility is dependent on temperature. And as I said, generally the solubility of a substance will increase with increasing temperature. We must pay attention to separation methods. Now, we are to look at a few of them. This is not a complete list, but it is sufficient to assist you with your CSEC chemistry. Evaporation. Evaporation is a technique that is used in the separation of a mixture, usually a solution of a solvent and a soluble solid. In this method, the solution is heated until the solvent evaporates, until the solvent turns into a gas, leaving the solid behind. That is evaporation. We can look at distillation. When a mixture consists of two or more liquids, distillation can be used. Here, the components of the liquid mixture are vaporized, condensed, and then isolated. The mixture is heated, and the part that is volatile will vaporize first. The part that is volatile vaporizes first. The vapor will then move through the condenser and is collected in the liquid state. That is distillation. We are separating two liquids based on a difference in boiling point. And then we have filtration. Filtration is the method used for separating a liquid from an insoluble solid. Take, for example, a mixture of sand and water. Filtration is used here to remove the solid particles, largely because the solid particles are large, separating from the liquid. And then we can pay attention to the separating funnel. The separating funnel is used mainly to separate two immiscible liquids. This involves taking advantage of the difference in density of the particles. For instance, oil and water, two different densities, two immiscible liquids can be separated by using this technique. As I mentioned, there are other separation techniques that you need to pay attention to, like fractional distillation. You'll pick up more of that when you are looking at your organic chemistry and the fractional distillation of crude oil. You may also pay attention to chromatography that will separate substances. For instance, the colors in a dye can be separated in chromatography by using a strip of filter paper. We separate the dye into its various colors based on the difference in density and the rate at which the component parts will travel up the strip of filter paper. Obviously, the lighter ones will travel faster. The lighter colors in the dye will travel faster and reach at the top of the chromatogram. The heavier portion, which travels slower, will be at the bottom, and so we have chromatography. I trust that this episode has been helpful to you as we have looked at the basics of mixtures and the various methods of separation. As I said in the introduction of the class, please pay attention to the definitions. You need to memorize these, but you need to understand the subtle differences that arise between them. You also need to look at why we are able to use one method of separation over the other. Like, what is the principle for using distillation, let's say, and we identified it as a difference in boiling points. All right? Please pay special attention to your work. As I mentioned, I wish you the best of success. Hard work pays off. Hard work pays off. If it is easy, it's not worth it. Continue to be committed. Continue to review. Continue to listen to the instructions of your teachers. And of course, continue to follow the guidance of your parents. Thank you so much. Until another time, I want to encourage you to leave a comment, share, subscribe, encourage your friends to come on board. If you've benefited from this lesson, why not share it? Thank you.